In science, graphs are a useful way of showing information without having to sort through a bunch of random numbers. Graphs show it visually so you can easily see what's going on. So again, a graph is a visual display of information or data, and there are three main types that we're going to talk about today. So before we get started, I want you to jot down some ways that people might use graphs in everyday life. Where have you seen graphs before? Hopefully you came up with some maybe business applications or sports applications or science applications that graphs can be useful for. So when you're making a graph, you're always going to want to place the independent variable on the x-axis and the dependent variable on the y-axis. Remember that the independent variable is the variable that changes the dependent variable. So in this case, time is what's changing, um, and as a function of time, the distance changes as well of the girl walking her dog. So you can see her distance is increasing, increasing, increasing. Then it stays the same for a while. Then she continues walking forward, and then stays the same. And then the dog appears to run backwards away from her. So she ends up looking like she's back home. So these types of graphs are known as line graphs, the first type we're going to look at, and they're good for showing how the dependent variable changes due to changes in the independent variable. So over time, the temperature might change in a classroom. Let's say someone is trying to install a thermostat. There's three different brands of thermostats, and he wants to test out which brand is truer to the control or the 20 degrees that it's set at. So he measures the temperatures of the three classrooms over the course of 25 minutes to see which one works best. Now thermostat A is the red line, you can see, um, does increase up to 20 and it appears to stay constant. Graph B is the blue line, which seems to just keep going and going and going past the 20, and the green line, thermostat C, doesn't even seem to reach 20 degrees Celsius over the course of 25 minutes. Uh, Another feature of graphs we often use is a break here, because we do want to use the same interval. Notice how the temperatures increase by 1 degree on each block, but there's no reason to include temperatures 1 degree through 14 degrees, so we put a little break here. That makes it a little easier to read, um, and it helps us choose an appropriate scale, because you can imagine if these were marked out in intervals of 50 degrees, the three lines would look very similar and it'd be hard to choose which one is actually most accurate. So again, just the two rules for making a line graph. Place the independent variable on the x-axis and the dependent variable on the y-axis. Make sure all your units match. So if you have a graph that's, if somebody tells you to graph something and they say graph the distance versus time, or maybe the temperature versus time, they're always going to list the dependent variable first, the independent variable second. So this goes on the x-axis this goes on the y-axis. So let's say we do have an experiment. We check the air temperature at certain hours of the day. At 8 a.m. it's 27 degrees Celsius. At noon it's 32 degrees Celsius. And at 4 p.m. it's 30 degrees Celsius. How would we graph our results? Well, first, why don't we make a table? We know that at 8 a.m., so we've got the time, we've got the temp. At 8 a.m. it was 27 degrees. At 12 p.m. it was 32 degrees. At 4 p.m. it was 30 degrees. So first we have to decide what my independent variable is. And that's the variable that's basically going to change no matter what, which is the time. Time, anytime you see time, that's going to usually be your independent variable. And then the temperature changes over time. So we're going to put temperature here. In degrees Celsius, and we're going to put time here in seconds. So we have an interval every 4 hours, so we'll say 8 a.m. 12 p.m. 4 p.m. and we'll put a little break here for our temperatures, and maybe we'll say start at 25, 30, 35. So at 8 a.m. it's 27. Find 8, graph 27. At 12 p.m. it's 32. And at 4 p.m. it's 30. Our line graph is going to look something like this. So it's not exactly easy for this particular graph to make a prediction past 4 p.m., but you might want to assume that the temperature is not changing very much, because I chose to use a small interval, but let's say we chose an interval something like let's say we chose 50 as our interval, and we had something like 0, 50, 100, and so on. Well, now our three temperatures are going to be 8 a.m. 27 is about right here, 12 p.m. 32 is about right here, 4 p.m. 30 is about right here. It almost looks like we have a straight line. So the interval you choose for your line graph or any type of graph is very important, because you can be very misleading depending on how small your intervals are. The second type of graph we're going to look at is a bar graph. These are useful when you're comparing information that you collected by counting. This one is sort of a simple example. Just how many hours of television did students watch per day? You can easily tell that from these bars that most students watch 9 to 11. And I'm hoping this is actually hours per week now that I look at it. That's what you might want to specify in your labels to make sure the person who's looking at your graph knows what you're talking about. So as you can see, about 32 students watch 9 to 11 hours, which is the highest result. And then you kind of see the lower numbers, and the higher numbers tail off as only about 4 students each watch those intervals of hours. Finally, the third type of graph is a circle graph. These are used to show how the parts fit together to make a whole. So how some fixed quantity is broken down. This one we have how many buildings in a community use different types of heating. You can see that half of them use gas, but that is the most common. Then we've also got steam, electric, coal, and other. Each of these parts make up the whole of the 72 businesses that make up the community. So how do we determine what percentage of that circle graph it makes up? Well, let's say there are 72 businesses in the community, and 18 of them use steam. Well, to get the percentage of steam, we're going to take 18 divided by 72, which on our calculator is going to give us 0.25, telling us it's 25 parts of 1 or 25%. Now to figure out the percentage of the circle this takes up, the angle you're going to measure with your protractor, we know that a circle is 360 degrees. So if we multiply that by 25%, we're going to get an angle of 90 degrees. And as you can see, the angle that this takes up is in fact 90 degrees. So just a couple of review questions before I end this lesson that I would like you to answer. Pause if you need to. Which variable is plotted on the x-axis? Which type of graph would best show the results of a survey determining people's favorite roller coaster? You ran your first marathon in 5.2 hours, your second in 5 hours, your third in 4.8 hours, your fourth in 4.3 hours, and your fifth in 4 hours. Graph the results of your races. Finally, 56 out of 245 people would rather drink orange juice than coffee. What percentage of a circle graph would this occupy? You can ignore that question. That's for a different class.